Hi there, welcome to EudretiX, where we make your high school life simple. I'm Aniket, and today this is part 2 of the hard difficulty for nonlinear equations in one variable and system of equations. This is the last topic for our digital SAT math practice in the advanced math section. Next we'll begin the algebra section after completing part 3 of the hard difficulty. So as usual, pause after each question, do it yourself, and then only look at our solution. Let's begin. Question number 1. Square root of 2x plus 6 plus 4 is equal to x plus 3. What is the solution set of the equation above? Not just the solution set. So let's see how many solutions we're able to find for this equation. It will essentially turn into a quadratic, which I can guess from here since there's a square root here. So let's isolate the square root on one side, on the left hand side. Square root of 2x plus 6 and get rid of everything else on this side. So x plus 3 minus 4. That's what we have. Now this becomes x minus 1, and on the left hand side it's square root of 2x plus 6. Now we'll square both sides. So we have 2x plus 6. This will come out of the square root symbol, and x squared plus 1 minus 2x. So combining everything on the right hand side, let's see. So x squared minus 2x, and then minus 2x from this side will come onto the right hand side, plus 1, which was already there, and then minus 6, which comes from the left hand side, is equal to 0. So x squared minus 4x minus 5 is equal to 0. Now let's try to find the solution. It's pretty obvious that we need to have a negative 5 when we break into parts. That should multiply to a negative 5. So this can be 5 and negative 1, or negative 5 and 1, since the difference has to be negative. So x squared minus 5x plus x minus 5 is equal to 0. X minus 5 plus 1, x minus 5. So x is equal to negative 1 and positive 5. Option C. These curly braces mean that inside these are individual values. So two values are possible. These are the solution sets. So that is option C. Okay, let's go to the next one. Next question. The graph of the function f defined by f of x is equal to negative half x minus 4 squared plus 10 is shown in the xy plane above. This is the graph. If the function g, which is not shown here, is defined by g of x is equal to negative x plus 10, what is one possible value of a such that f of a is equal to g of a? Essentially, they're just asking about a point of intersection between the two functions, or a solution of the system of equations. There are two methods to do this. First method, you solve it directly, solving. Second method is Desmos. We could check through Desmos graphing calculator. Okay, let's go by the first one first. Okay. So negative half a minus 4 squared, since a is the value of x, which is a solution to both, is equal to negative a plus 10. Now subtract a 10 from both sides, and then we're left with negative half a minus 4 squared is equal to negative a. Negative signs cancel. You can multiply with a 2 on both sides. So this 2 and this 2 cancel. It becomes a minus 4 squared is equal to 2a. Okay. So these steps were quite fast. Maybe just pause and rewind to see if you follow each step. A squared plus 16 minus 8a, that's the expansion of a minus 4 squared, is equal to 2a. So a squared minus 10a, if I pull the 2a to the left hand side from the right hand side, plus 16 is equal to 0. 16 is 8 times 2. That's how we'll break it. A square minus 8a minus 2a plus 16. So you get a minus 8 minus 2, a minus 8. So a is equal to 2 and a is equal to 8. Both of these answers are correct for this question. Okay, both answers are correct. The other way is to go by the Desmos graphing calculator. We can see that as well. This here is the Desmos graphing calculator. So we'll insert the equations one by one in this calculator. First equation is negative half x minus 4 squared plus 10. So negative half x minus 4 squared plus 10. This is the first equation. Second equation is going to be negative x plus 10. Negative x plus 10. Okay. As you can see here, we can see two intersection points right here. And what are these? 2, 8 and 8, 2. Exactly what we'd got. One x coordinate is 2, one is 8. We got 2 and 8 there as well. So let's return to our original question. So these are the two methods of doing this. Moving on to the next question. Negative 16x squared minus 8x plus c is equal to 0. This equation is given to us. In the given equation, c is a constant. The equation has exactly one solution. What is the value of c? This is a quadratic equation and they're saying that it has exactly one solution. That means it has two real but identical roots. Real identical roots. Okay, so in that case, the determinant, as we have seen, the determinant b squared minus 4ac is equal to 0 for identical roots. B in our case is negative 8. So negative 8 squared is 64. Minus 4, a is negative 16, which is the coefficient of x squared times c. This is equal to 0. Okay, so this becomes a positive here. 64 plus 64c is equal to 0. So c is equal to a negative 1. When you transfer this to the other side, 64 is equal to negative 64c and c is a negative 1. That's the answer. Okay. So the determinant is equal to 0, two identical roots, greater than 0, two real and distinct roots, and less than 0, no real roots. Okay. Next question. X minus 1 squared is equal to negative 4. How many distinct real solutions does the given equation have? Okay. Now here I'm going to show you another method. This is a pretty obvious question. X minus 1 squared. Anything squared would be positive. Either positive or 0. Those are the only two choices. Negative 4 here is a negative number. These two can never be equal. What's the other way? The other way is to actually draw the graph of this. X minus 1 squared. That means x is equal to 1 is the vertex. It's a parabola opening upwards with its vertex at x is equal to 1 and y is equal to 0. 1, 0. And negative 4 is a line here. Y is equal to negative 4. Are they ever going to touch? No. No point of intersection. So these are other qualitative ways of checking the nature of the system of equations or whether something has a solution or not. You don't exactly require to solve the complete equation each time. Okay. So there are distinct real solutions, 0. 0 real solutions. Okay. Let's go to the next one. The next question has two equations. Y is equal to x squared plus 2x plus 1. X plus y plus 1 is equal to 0. If x1, y1 and x2, y2 are the two solutions to the system of equations above, what is the value of y1 plus y2? Okay. So two important points. First thing is to find the solutions for this equation, the system of equations. And then the next thing is to find the sum of the y coordinates of the solutions. Okay. Let's begin. First equation is already in terms of y. Second equation would become y is equal to negative x minus 1. Let's equate both of them. Negative x minus 1 is equal to x squared plus 2x plus 1. Since both the y's would be equal. X squared plus 2x. I add a positive x on both sides to get rid of this negative x on the left hand side. So this and this cancel. On the right hand side, x squared plus 3x. Okay. Then I add a 1 on both sides to get rid of the 1 on the left hand side. This becomes a 0 plus 2 is equal to 0. This is the quadratic equation that we have. And it's pretty obvious, it's 2 times 1. x squared plus 2x plus x plus 2 is equal to 0. Okay, so the simple solution, like the quick trick to do this is, as soon as you figure out what two numbers you want to split this into, so we're splitting it into 2 times 1, the solution straight away would be -2 and -1. So x is equal to -2 and x is equal to -1. These are going to be the solutions of this equation. Now corresponding to x is equal to -2, what is the y? Y we can find from here. If x is -2, negative of -2 minus 1 is a 1. Okay, this is y1, let's say. Okay, now x is equal to -1, so y is equal to negative times -1 minus 1. 1 minus 1 is a 0. Y2 is a 0. So y1 plus y2 is 1. Option D. That is the correct one. Okay, let's go to the next one. If u minus 3 is equal to 6 upon t minus 2, what is t in terms of u? Okay, this is again a case of rearrangement. We have to rearrange the equation such that it is it represents t in terms of u. Okay, so one by one we'll isolate the t. First of all, we'll get it into a numerator. So multiply both sides with a t minus 2. What do we get? U minus 3 times t minus 2 is equal to 6 upon t minus 2 times t minus 2. Multiplied both sides. This and this cancel. So now we have t minus 2 in the numerator. Now we'll get rid of the u minus 3 from the left hand side. For that, divide both sides with the u minus 3. This and this would cancel. The left hand side u minus 3 and u minus 3 in the numerator and denominator, they cancel. T minus 2 is equal to 6 upon u minus 3. Next, we get rid of this -2 with the t. So add a 2 to both sides. You get t is equal to 6 upon u minus 3 plus 2. Solving this, we get 6 plus 2u minus 6 over u minus 3. This is equal to t. 6 and 6 cancel. 2u over u minus 3. That's option D. So that's how you rearrange the expression to get it in whatever way you need. Okay, in the way you need, that is representing t in terms of u. So here we conclude with part 2 of the difficult questions, the hard difficulty questions for nonlinear equations and system of equations. Make sure you have understood all the solutions properly. If you have any suggestions or any doubts, hit me up in the comments, or you can send across an email, or you can simply head to the EudretiX website and contact us from there. Okay, so keep practicing, take care, be ready for part 3 of the hard difficulty. Thank you, bye-bye.